Okay, welcome back, and now we're going to talk about graphing logarithmic equations, logarithmic functions. And we're going to start by a little bit of review with regard to the exponential. Okay, so now, if you remember the characteristics of the exponential, which I highly recommend that you do, then graphing logarithmic functions are going to be a piece of cake. Okay? Because if you could transform, there are a couple of different ways you could do this, but you could transform a log, right, into its equivalent exponential form, and then you can get the characteristics, the points and stuff from the exponential form, and then you switch it for the logarithmic form. So that, and you'll see what I mean in a moment. So that's one way of doing it, because what you're using is the fact that they're inverses of each other and there are reflections across each other. When you reflect across the y equals x, so that's this line here, so the identity function. So when you reflect across that line, well, what you're doing is you're flipping the x and the y's. Okay? And so so that is something you can do to help you graph logarithmic functions, is look at the equivalent form, the exponential form, okay, the inverse. Okay, so here are the characteristics that are going to help you graph any logarithmic function. So first of all, it's a one-to-one function, okay. Vertical asymptote, like I said, is at x equals 0. It's the y-axis. The domain is 0 to infinity. We talked about that. The range is all real numbers. The x-intercept, notice it's 1, 0. Remember, with the exponential, it's 0, 1, right? Here are the other two important parts. Notice that with exponential, we had 0, 1, 1, b, negative 1, 1 over b. Well, now it just switched, right? So the 3 points that all logarithmic functions will go through is 1, 0, b, 1, and 1 over b, negative 1. So as long as you know those 3 points, you can graph the logarithmic function. And there is no y-intercept. Okay? So here we have an x-intercept and no y-intercept. With the exponential, we had a y-intercept but no x-intercept. And the y-intercept was 0, 1. Okay? Of course, it's an increasing function if b is greater than 1, and it's a decreasing function if b is between 0 and 1. And that's the same as what we had before with exponentials. And so here's the two forms. So this is if b is greater than 1, it'll look like this, right? If b is greater than 1. If b is between 0 and 1, it'll look like this. So it'll be a decreasing function. And again, it's because it flips across, it reflects across the x-axis. Okay? And the base, remember, the value of the base will affect how this curve looks, as far as how pronounced the curve is. Okay, we saw the same sort of thing with exponentials, right? Depending on the base, will tell you how steep the increase is. Okay, and that's it. So those are the characteristics that you're going to want to keep in mind. That's going to help you graph any of the logarithmic functions you're going to come across. Have a good day.